Hello students, so today we are going to discuss the line plotting in MATLAB. So we are going to see that how different mathematical functions can be plotted inside the MATLAB. Okay, so in order to do it, let us first go inside the script here, and here let me first write the CLC and then clear all. Okay, so after it, what we have to do in order to plot anything, what we should have, we have some values in the x-axis, and the x-axis we can call it as the independent variable. Okay, so writing x here, so let me write x here and let me start it from 0 and I will end it at 1. Okay, so by writing it like this one, what I am going to do is that I'm starting the x variable from 0 to 1 with the difference between both of these digits as 1. Okay, so in order to reduce the distance here, what I can do here, I can write another column here, and between them I can write here any number with which we want these two to be apart. Okay, so any two digits here will be apart with the digit or with the number here which I am going to write here. So let me write it as 0.01. okay, so now this is x variable. Okay, so now in order to plot any other variable, let me plot here first. So let me have here the y equal to 0.5. okay, so that is y equal to 0.5, and what I have to do, I am going to plot it here from 0 to 1 with the distance between each digit here as the 0.01. okay, so after it, what I am going to do, I am going to write here plot. Okay, so plotting it, what I will write here first, I will write the x variable and then the y variable. So after it, let me save it. Okay, and let me save it with the plt name. So saving it and now running it, what I can see here, we can see that the line here is at 0.5, which is very thin here, and we can increase the thickness here as well. How can we increase the thickness? First of all, let me change its color. So in order to change its color, what I can do here, I can write these inverted commas, and in between them I can write R or C or B. Okay, so B is for blue, R is for red, C is for cyan, and similarly K is for black. Okay, so let me write here R and then printing it again. I can see here easily that the line here is now red colored. Okay, similarly, in order to increase the width of this line, what I can do here, I can write this inverted commas and line width, and increasing the width up to 4 here. Let me see it now. Okay, this, or let me increase it by 6. Okay, so we can see that the width has been increased with this one. Similarly, in order to plot any other variable here, let me plot here the exponential. So exponential is exp, and writing it like this one and writing it with minus x. What I can do here, let me print it, and I can very easily see that this is the exponential decay with the initial value of 1. Why is it 1? Because it is the multiplicative factor here, or the coefficient of exponential term here is 1. Okay, in order to reduce the width of this line, what I can do, I can reduce it here, and here after it, what I will see it like this one. Okay, so in order to print here some grids as well. Okay, so writing grid here, what will happen, we will see that the grids will appear here as well. Similarly, in order to write the title of this plot, similarly x label, y label, what I can do here, I can very easily come over here and can write here, first of all let me write the title. So in title I can write here in between the inverted commas as the plot, or let me call it line plot. Okay, similarly x label is the term which I want to be appeared on the x-axis. So on the x-axis I have, let me call it the time. Okay, and over the while y, what I have the amplitude. Okay, so now let me print it, and I will very easily see that here the title is line plot. Over the y-axis I have this amplitude, while the time variable has been shown here on the x-axis. Okay, so this is one of the very important properties of the plotting here. Okay, similarly what I can do here, that I have some more mathematical functions like the trigonometric functions, and those are sine and cosine signals as well. So let me write here the sine function which have the frequency of, let me call it 10 hertz. Okay, so if the frequency of it is 10 hertz, so let me write the sine, and inside the arguments here, what I will have, sine of 2 into pi into f into x. Okay, so that is the value of sine here. Now let me print it here. What I will see, that these are the values of the sinusoidal function, which I can see here very well. Okay, in order to increase the resolution of my plot here, what I can do here, I can increase the distance between each and every point here, and by reducing the distance, this is the reduction. So by reducing the distance between the points, what will happen, the number of points will increase, which will ultimately result in the increase of the resolution of my plot here. So if when the resolution is higher, I will see that the plot here will be crispier as that of the previous one. Okay, so similarly if I will decrease it like this one, you will see that the plot will be like this one. It is not a very good plot. Similarly if I will increase it like this, if I will increase the number of points by reducing the distance between the points here, it will be like this one, and similarly it can also be increased as well. Okay, so this is all about the sinusoidal waveform. Similarly, what if I have another waveform here, and that is y2, and writing y2 as cos, and cos of 2 into pi into f into x. Okay, and what if I want to plot them here as well? So when I will plot them here as well, what I will do, I will let me write here plot. Okay, that is x and that is y1. So now let me plot it. Okay, sorry, that is y2 here. Now let me plot them here, and I will see that only the cosine plot will appear here. Why is it? Okay, you will see that only the cosine plot is available here, but not the other one, which is this initial plot. Why is this? Because now the only one window will be replaced by the last one. So if I want to plot them both, what I can do here, I can write here figure for the first one. Okay, and similarly figure for the second one as well, and when I will plot them, I will see that both of them are now plotted separately. This is for the sinusoidal, while this one is for the cosine plot. Let me differentiate them by using different colors here. For the cosine I am for the sine I am using red color, and for the cosine I am using the cyan here. So you will see that both the plots are here. Now you can see that the title at x label, y label is only with the last plot here. Why is it? Because these commands are basically connected with the last plot here. Okay, so what if I want to plot them on the single plot? What I can do here? So in order to plot both the curves over a single window, what I can do here, that after writing the plot command for the first figure, I can write here hold on, and after it writing another command here, this will plot both of them on the single window here. Okay, similarly now let me change the color here, let me make it black, so the difference will be now clear. Similarly now let me increase the width. Okay, line width is, let's say again 2 and similarly printing it, I will see that now both are printed here. Similarly, let me increase the number of points here, and I will see here that the plots are now crispier, but you can very easily see that both are plotted here. Okay. Similarly, if I will reduce the frequency here, and now let me print it again, I will see that both the plots are available here. So the red one is the sine one, the blue one is the cos one. So it is very difficult for me to see or to differentiate between both the curves here. So in order to differentiate them, what I can write here, I can write another thing here, and that is the legend. Okay. So in legend, what I can do for the first and for the second, I have to write two things here, and for the first I have sine of x, or write sine, and for the other one let me write cosine. And when I will print them, what will happen, now you can see that the legend is now available here. Okay. You can also move it with the cursor here as well. Okay. So that is all about the plots here. Similarly, if I don't want to write these plots separately, what I can do here, I can only cut it from here and also write it here as well. Okay. So writing it here as well will serve the same purpose. What is the issue? Okay. So it is basically not allowing me to write both the line widths and colors in both the line widths in the same plot. So let me change it now. Now let me change it. Okay. You will see here that just writing only one line width here, it will serve the purpose, while the color of both the plots are now separated from each other. Okay. So that is all about the line plot here. Similarly, what if I want to plot them separately or the separate plots in a single window? So what I have to do here, the concept of subplot is introduced here as well. Okay. So in order to plot them in a single column double row figure, what I can do here, I can write here subplot, and in subplot what I can do, let me have two rows, one column, and this is my plot here, and in the case of this two rows one column, this is my first plot. Similarly here, let me remove this, hold on, and here subplot two rows one column, and this is my second plot. Okay. So let me run it now, and you will see that in this one column and two rows I can see that the first one here is the sinusoidal waveform, while the second one here is the which one, cosine. Why is it showing this one? Because I am using legend with the second one only. So let me remove it, and similarly using these two with the upper one as well, and now printing it, what I will get, I will get this grid lines with both the plots. Similarly, the title, xlabel, ylabel with both the plots. Similarly, what if I want to plot them in a single row double column? What I will do, I will just change here I will just write here one row two columns. Okay. Similarly here one row two columns. So this is the first one row two column overall plot, while this one is the first plot, while in the one row two column plot, this is the second one. So let me printed them now, and I will see that the printing is now done like this one. Okay. So that is all about the prints now. So today we have seen that how to print different functions inside the MATLAB and how to compare them visually on the basis of different plots. Okay. So next time we will also discuss some more plots. Till then, take care of yourself, and I will see you soon.